Today we're going to look at trigonometry. Ratios between corresponding sides of similar right-angled triangles are constant. What that means is if we've got two right-angled triangles, the angles are the same in them, so we look at the angle being exactly the same. Doesn't matter if they're a different size. If one of those angles is exactly the same, that means that when we look at the ratios between different sides, they will be constant. So for example, if we're looking at these two triangles here, we look at the side that's opposite the angle, the side that's opposite the angle, and divide that by the hypotenuse. In each of those triangles, that ratio will be constant. So 3 is the opposite side here, divided by the hypotenuse 5, and 6 divided by 10 here. We can see that ratio is constant. So I can multiply by 2, multiply by 2. So it's the same with the adjacent side. Adjacent means the side that's next to the angle. It's the same with those ratios as well. So the ratio of the adjacent side to the hypotenuse, 4 to 5 and 8 to 10. They are exactly the same, and it's the same with the opposite side divided by the adjacent side. So this is a ratio. It's a fraction, but it's expressing as a ratio between those two sides. So we can therefore say that there is a relationship between the angles in a right angle triangle, so the angle that we've got here, and the ratios of those side lengths, because we know that that angle relates to the ratio here. And if whatever this angle is, it will always, if we keep that angle constant, the ratio between the opposite side to the adjacent side will always be 3 over 4. It will always be that. So it means that we can actually use some special ratios and relationships now to actually determine different side lengths, determine different angles as well. So they've given, these ratios are given 3 different names because there are 3 different ratios in a right angle triangle. The opposite side, the side opposite the angle to the hypotenuse, the side that's adjacent to the angle we care about divided by the hypotenuse, and the side that's opposite the angle divided by the adjacent side. So these 3 ratios are given these names: sine, cosine and tangent. You might see them abbreviated to sin, cos, tan, but often we'll say sine, cos and tan. So what these ratios mean is if I say, okay, I'm going to find the sine of our angle theta, that's this Greek symbol here, theta, then that sine of that angle is always going to be the ratio of the opposite side to the hypotenuse. And if that angle is constant, so if it's 45 degrees, this ratio here will be constant as well. It will always be the same value. So with cosine as well, cosine relates the adjacent side to the hypotenuse, and the tangent ratio, the tangent function ratio, relates the opposite side to the adjacent side. So in our triangle, if we've labelled where the angle that we're looking at is, the opposite side to that angle is the side that's furthest from it. The adjacent side is the one that is next to it, next to the angle, and the hypotenuse is always the side that is opposite the right angled triangle. So to remember this ratio, or remember each one, to remember the difference between the different ratios, that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, we can use the abbreviation SOHCAHTOA. So what this means is the sine function, the sine tangent, the sine ratio rather, the sine ratio is opposite over hypotenuse, the cosine ratio is adjacent over hypotenuse, and the tangent ratio is opposite over adjacent, or the ratio of the opposite side to the adjacent side. So let's try and understand it by looking at what this means in practice. So if I've got a triangle here, I've got a right angle, I've labelled the angle here. I don't know how large that angle is, but I've labelled it here. And I've labelled the sides 36 for the adjacent side here, 15 for the opposite side, and 39 is the hypotenuse. So this side here is the adjacent side. This side here is the opposite side. That's the opposite side, and this is our hypotenuse here. So hypotenuse is 39, opposite side is 15, and our adjacent side is 36. We're being asked to write simplified ratios for sine theta, cos theta, and tan theta for the following triangle. So we're looking at what are those ratios going to be for this particular triangle. So we first always start by writing out our definition for each ratio. So the sine ratio, sine theta is opposite over hypotenuse, always. So we can substitute in then, the opposite side is 15, the hypotenuse is 39, 15 over 39. Simplify that by dividing the top and bottom by 3, and we get 5 over 13. For cosine, the cosine ratio, cosine of the angle, that's the adjacent side divided by the hypotenuse, the ratio of the adjacent side to the hypotenuse, 36 over 39. Once again, divide both of the top and bottom by 3 to simplify it, 12 over 13. And tan of our angle, the tangent ratio is opposite over adjacent, so the opposite side is 15 over 36, 5 over 12. So even if this triangle doubled its size, if all of the angles remain the same, that ratio would still be the exact same. So the tangent ratio would still be 5 over 12 for this triangle. The cosine would be 12 over 13, and the sine would be ratio would be 5 over 13. Now we're going to look at applying algebra to be able to determine some different side lengths. On your calculator, the sine, cosine, tangent ratios are given as in their abbreviated form. So if you want to find what ratio a particular angle is, you can just type in or press the cosine, sine, tangent button, and then the angle that you're looking for. And that will give the ratio of those sides for any triangle with that angle. So if we have a look here at our first triangle, we're being asked to determine the value of x in these triangles correct to 2 decimal places. So our triangle here, we've got our hypotenuse is 10, because that's the side opposite our right angle, and our value x here is the adjacent side. It's the adjacent side here. So whenever we're looking at solving a problem here, we need to analyse what ratio we need to use, or what ratio is being represented in front of us. So we don't have the opposite side. We cannot use the opposite side. We've got the adjacent side and the hypotenuse. And because we've got the adjacent and the hypotenuse, we need to use the cosine ratio, because cos is, or cosine of the angle is equal to the adjacent divided by the hypotenuse. So if we have a look here, we can write our definition. Cos of our angle is adjacent equal to adjacent over hypotenuse. So we can substitute in our values. So our angle, theta, our angle here is 24 degrees. So cos of 24 is equal to, our adjacent side we don't know is x, and our hypotenuse is 10. So we've got now an equation, cosine of 24 degrees equals x over 10. If I multiply both sides by 10, that will make this 10 divided by 10. So it'll be 1, and they will cancel out effectively. And so I'll be left with 10 times, we've got a little times in there, 10 times cosine of 24 is equal to x. If I put this into my calculator now, 10 times cos, the cos button, and then 24, don't need to put the degrees symbol into your calculator, cos of 24, it will give us 9.14 and many other decimal places, but we've been asked to round only to 2 decimal places, so our answer is 9.14. So that's our value for x. So what are those steps that we've done? Firstly, we tried to find which ratio we needed. We know that it's cosine because we've got the adjacent side and the hypotenuse. We write down our definition for that ratio. we substituted in values. So our first was determine the ratio that we need to use. 2 was write the formula, write that relationship. 3, we substituted. And our fourth step, we solved. We solved by using algebra there. Let's have a look at our next ratio, or our next triangle. So, determine the ratio. We need to find what ratio we need to use. So we've got our opposite side, the side opposite our angle, and we've got our hypotenuse. And because we've got our opposite and our hypotenuse, we need to use sine, because sine of our angle is opposite over hypotenuse. We write down our formula, sine of theta equals opposite over hypotenuse, substitute in our 35 degrees, 5 for our opposite side, and x for our hypotenuse here. If we multiply both sides by x, we get x sine 35 degrees equals 5. By multiplying by x, we cancel out x's on this side, multiply on this side. And then to obtain x by itself, we need to divide both sides by sine 35. Now sine 35, remember, it's a ratio. So sine 35, cos of 24, they're all just ratios. So that is just one value, one number. So I can divide both sides by this whole number here. Okay, so this is one number, and I can divide both sides by that. So I have 5 divided by sine 35, put that in my calculator, and I get 8.72 when I've rounded it to 2 decimal places. Our last example here, we have our adjacent side, the side that's adjacent to our angle, and we've got our opposite side. So we've got our adjacent and we've got our opposite. So because we've got adjacent and opposite, we need to use the tangent, our tangent ratio. So there we've determined the ratio we need to use, tangent ratio. Tan theta, we'll write our formula, tan theta equals opposite over adjacent, substitute in values, tan of 28 degrees is equal to 19, which is our opposite side, over our adjacent, which is x, multiply both sides by x to get x tan 28 degrees is equal to 19, and and then divide both sides by the tan 28. Remember, this is one number, so we can divide both sides by the tan 28. 19 divided by tan 28 is equal to 35.73.